Good day, class. Today we'll be discussing basic programming 2. In our former class, we've already discussed about the basic programs. We discuss about the rules to follow, and we also talk about the constants, all the variables, and the operators that you need to use in dealing with basic programming. So, how we talk about that basic program means beginner all-purpose symbolic instruction code that was developed from America by 2 students when they are following their instruction of their professor. So today, our major goal today is just to focus on the inbuilt of this basic program. But to refresh our brain, we just work on probably maybe 2 examples before jumping into the inbuilt of this basic program. So the first example, the first question I have here is that we are going to write a basic programs that accept 2 numbers and find their sum and the difference. So these programs, we accept values from the user, it will find the sum and also the difference. So you can start by your rem, which is remark, and I say you can put a line here. So you can start rem program to find the sum of 2 numbers and its difference. So this program will accept number from the user. So then our next line will move to 20. So what do we have to do? We have to input. We have to tell the user to input something. So we now say input. So now to make the program more interactive, so we now say input. Enter your first value or number. Okay? You close it like this, do something like this, and you can say A. Why do we do this? In our first class, I said that anything that is in double quotation is called string. So this thing is what that will first of all show on the screen when they run this program. The user will obviously enter a first value. So the user will be able to input the first value. Then 30. You now see collect the second, enter your second value or number. So now you can use this one as B. So what we want to do is that we need the sum and we still need the difference. So we can just go straight to 40. You can now say let sum equals A plus B. So now you can now say 50. Let, what do we still need? We need diff equals A minus B. So 60 now, you cannot print it out. You cannot say print sum. Or to make it more interactive, you can say something like this. Print the addition or the sum of the 2 number. You can now equal to, now what is it? It is sum. Sum. So same thing here, coming here, 70. Print the diff or the difference, write complete the difference between the 2 number equal to diff. So and you're 80. You can hand the programs. So now what we did in here is that before of us accept what the user is bringing in. What the user, we don't know, maybe it's 50 or it's 60. So we try to accept it. That's why we say enter your value, and any value that the user input will be stored in here. Same thing occur in here. And here is where we just did the process. So while A and B will be stored in here, A minus B will be stored in here. And the 60 and 70 line, we try to print out the operation that we perform. So and the 80 is always, and I always tell you, we are dealing with something that is, it follows steps. So once you start, you have to end. The rem is just a remark for the program that you want to write. So the second example that I have in here, the second example with me is a program to calculate the perimeter and area of a rectangle. So now I would like to clean this. So now the question that we ask is, so write a basic program. Write a basic program to calculate area and perimeter of a rectangle. And you know that area of a rectangle equal to L times B, while the perimeter equal to 2 open bracket L multiplied by B. So that's your mathematics. I've already tell you mathematics and computer, they work hand in hand. Even when you reach an institution, you still have to join physics with it. So you really need to understand your math very well and take your physics serious as well. So now, dealing with this in Key Basic, what we have to do, we have to first remark it, and you can start with your CLS. I've already told you the function of CLS in our former class. CLS clear the previous. Once you run a program, let's say this is your key, you are using Key Basic, you run a program in here, and the program CLS will help you to clear, to remove all the previous memory and bring in the new one that you want to deal with. So you can start with your CLS line. At the same time, you start with your 10. You know, it's very important to your line. So you can rem and remark it. Remark what? Program to do what? To calculate area and what? Perimeter of what? Of a rectangle. So now, the next line, you're coming to line 20. So now, the problem we have now is that we don't even know the length, we don't even know the breadth, because they did not tell us. Let's say they tell us that L equal to 4, B equal to, that's another scenario, but in this scenario, they don't tell us. So we have to accept it from the user. So we still go input. Now, to make it more interactive, I told you, you put this in string. Input, you can still put another input, or you can use enter the value of the length of your length. Yes, let's use of the length of the rectangle. Then you close it. So that's the string. So now this we now put L. So the next one, which is 30, we still input. Input is a command for the user. We are just sending a command to the user that input this. And what should I input? That's why we now say enter the value of the length of the rectangle. So here we now say enter the value of the breadth of the rectangle. And this will be B. So now we have our length and we have our breadth. What else? We have to find our area. So now to find the area, we know that the formula said L times breadth, which is length times breadth. So now we now come to line 40. Our line 40 will now be let A equal to L multiplied by B. So that's it. We have our area. Now to have our perimeter, say line 50. You know, I told you when naming variables. Let's say you can use P, you can use Perry. You can use Perry, yes. But I told you cannot use P, you cannot use 9P. No, all these are very wrong. We've already discussed in our previous class. So Perry equals to open bracket L multiplied by B. Then close the bracket. Then what else? After we've already do the process, the next thing that we have is just to print our answer. So normally you can just print your A directly, and that will print your area. But to make the program interactive, we have always tell you to make your program interactive so that anybody, even a layman, can even see, okay, this is what this program does. So to make it more interactive, that's why we now said print the area of the rectangle equal to the semicolon and A. So now to now print this our Perry, so that will be 70. So it will now be print the perimeter of the rectangle equals to, this has become a string. So peri. So now we now have our 80, which is hand. So this determines the programs. So that's how you calculate the perimeter and area of a rectangle. This formula for perimeter, and this formula for area, and this formula for perimeter. And after you can represent this one with Z, you can represent with perimeter complete, you can represent with P, doesn't mean, but you cannot start with 5P hash P. So we've already discussed that in our previous class. Okay, focusing on major business of the day, which is inbuilt functions. So the inbuilt functions are the ready-made functions that are inside the basic program, whether you are using your Visual Basic or you are using your Key Basic. So the inbuilt function is already in there. You only just to know how to explore it, how to make use of it. So I'll list some of it that we have. We have the exponential, we have the int, we have the absolute, we have the sine, we have the tan, we have the cos. So there are a whole lot more about that. But we are going to discuss about this today. So the exponential, the int, the absolute, the sine, the tan, the cos. So in your mathematics class, they may give you a question like find sine 30, find cos 45, find cos 45 plus 95. So with basic programs, you can compute that. So now, coming to your mathematics, in your quadratic equation, you have a formula like minus b plus or minus root of b squared minus 4ac divided by 2a. That's your quadratic formula. Some people call it almighty formula. So now, looking at this kind of equation, now they say that you should compute something like this in basic program. They give you, maybe I said z equal to root of b squared minus 4ac divided by 2a. Compute this in basic program. So how will you do this square root? So that's why we need the inbuilt functions. That's where the inbuilt function came in. So you don't really have to stress yourself. So we have SQR. So the SQR stands for the square root. So it's what you use for the square root. So anytime that you see the square root, you use the SQR. So now, let's solve this. So we know we start with rem. Your rem is your remark. So you can say program to solve the equation. Our equation doesn't have name, so we can put the name in there. So now the next thing is to go with your line 10. So now after this, what do you have next? What do you have next? So you can now go with, you have to input your B, you have to input your C, you have to input your A. So now that means that you have to accept value from the user. Because I assume that I said B equal to 10, A equal to 15, and C equal to 50. That means I've already given you the value. But no, this doesn't happen in this situation. In this situation, you have to accept the value from the user. So accepting value from the user, so we use inputs. Input. To make it more interactive, I always say you make your program interactive so that everybody can understand it. So now, what do you want to input? Input. Enter, you can even put please, enter the value for A. So, and you can close your string and put your small letter A in A. So now, 30, input, enter the value for B. Close your string and put your B in here. So your 40, same thing, input, enter the value for C and put your C. So now we've already accepted all the values that we need. So what else? We have to process, we have to solve the equation. So solving this now, it's already given us Z. So we have to put everything in here, we have to put it inside the Z. So we now say line 50. Yes, we have something like this. So let Z equal to, you now put your SQR, which is your square root. So you cannot just write square root on key basic program and say it will no. You use your SQL, that's why we call it inbuilt function. So the basic have already know that okay, this person need square root, so to just bring out the square root from where it's keeping it before. So now you have your SQL. So you now open your brackets. You now have your B raised to power 2. We use this symbol for raised to power. So now you subtract it from 4, multiply by your A, then multiply by your C, and you close the bracket. What else do we need? All these are over 2 multiplied by A. You can put those ones inside brackets. So now we've already performed the function. We've already performed the equation, the major headache. We've already solved it in here. So what we need now is just to show our answer, show the output. So now you go to 60. So you now print. You can just print your Z, the answer will come out. You can see do it like a print. The solution of the equation equal to, put your equal to inside the string. Now close it, what is it? Z. So now, and your 70 will end and terminate the program. So that's it. So see how this equation look very complicated, look very sophisticated, but we try to break it down in basic program. So we accept all the value, we accept the value for A, we accept the value for B, we accept the value for C. And here we now use the inbuilt function. So SQL, so now that is okay, B squared minus 4A multiplied by C, then over 2 multiplied by A. So now let's look at more sophisticated equation. So that we are going to solve. So I have a lot of example in here. We have something like this: x minus y, x plus y in close brackets. We still have something like b equal to 1 over 4 ac. Yeah, and the last we are going to treat today is e is for x squared plus y minus sine open bracket x plus and y, then close the brackets. So these three stuff, we are going to solve them with basic program. So when you see any equation that they tell you to write basic program for, you shouldn't be scared. You just study the equation very well and break it down into smaller pieces. That's why we start from Q basic, we go to flowchart, we start from algorithm and we solve the flowchart. So we follow it step by steps. So I'm going to clean this. So now, in solving this first one, x minus over x plus y. So, you use your RAM program to finish down. Then you come to input. Okay. Let's make it more interesting. I said let x y equal to 10. So now, if I already tell us what x is, they tell us what y is. So now, writing this, you say RAM. So we said RAM program to solve equation. The equation of our name, you can replace it with it. So now, we have our x as 5 and our y as 10, and we are solving this equation. So we can now say let, you start your 10, your 20, you follow it. Let x equal to 5. So we declare it. That's the declaring variable. We declare it. So 30. Let y equal to 10. So now the program have already know that whenever I see x, I represent it with 5. Whenever I see y, I represent it with 10. So now moving to line 40. What are we doing? We are dividing these two things. Okay. You can set everything equal to m or z or k. So now let k equals to open bracket x minus y divided by x plus y. Yes, it's possible you can do something like that. And now 50 will print the answer out. So print the solution to the equation equal to, then you close your string and bring this out and bring your k at the back. So your 60 will hence or terminate the program. So what we did is very simple. You just tell the program that our x is 5 and our y is 10. And the major equation in here will bring it here. So another thing that you can do in here is that to make the compiler, to make the work easier for the compiler, to make the work easier and faster for compiler, you can do something like this. You can say x minus y equals to n, x plus y equals to n. So now, here, k will just be k equal to m divided by n. Don't worry, we are going to use that kind of method in this second example. So you'll be able to get what I'm trying to say. So to make it easier for compiler to read and for fast operation, so you can break down, once you have an equation that is very long, you can just break it down for compiler. So now, let's deal with this second equation. Now we have the second equation as b equals to 1 over 4ac. So these are 4ac. You can represent it with x. Yes. You can represent this, and this one, you can just leave the 1. You don't need to represent it with anything. So now, writing basic program for this, we start rem. Let's call it overdose equation. So rem programming to solve our overdose equation. So now, continue. What do we need? We need to input our A and C. We need it. So input, because they did not give us the value of A and C, so we have to collect it from the user. And we ourselves we do not know it. So we have to collect it from the user. So we have to tell user input, enter the value for A first. Then you close your string, close it like this, and bring in the small letter A. Then you can now say input again, input, enter the value for, we have our C, put your string, and put your C here. So now we collect the two variables that we needed. So now moving to line 40, we want to solve for A and C. So we now said, let what? We said we are going to represent it with x. Let x equal to 4 multiplied by A multiplied by C. So moving on, we now said 50. Now we are now bringing our normal equation, which is let B equals 1 over x. See? So there's no magic in here. We just try to break it down for the compiler. So we just help the compiler, we lessen the work of the compiler. So before we solve for this, I will now store all the answer of this 4 multiplied by A and by C. We'll store it inside x. Then the x is still a numerator, so we'll bring it back, we'll demote it back to the numerator that it is before. So now coming to 60, all we have to do, we just have to print our B. Print B, and you can say solution to what we call the name overdose. You can say is, and you can say equal to what, which is B. So on your 70, you have to end. You have to terminate the program. So that's it. That is it. So now, looking at this, our last equation, we see that we have one E is here, and this is stand for exponential. So, and that's what we'll be discussing today. And you can see it here, exponential. So it's still an inbuilt function. It's an inbuilt function in the program language. So now, sorting for this, sorting for that. So now, don't look at it as if it's too complicated, but just have to bring it down. So you have your exponential, you have your x squared plus y minus 9, x plus ny. So you are going to need to collect the value for x, you need value for y, you need value for n. So you can input it like this, at the same time you can collect it together. Let's see what we did. Program array. I told you can start with your CLS. The function of your CLS is that when you are running a program, let's say you are using a QBasic, you first of all write the program to find even number. So once you use your CLS next, your CLS clear the previous memory. It deleted the previous memory of what you did in your QBasic, or maybe probably you are using Fashion Basic. So you can start with your CLS. There's no crime in that. and can solve the rem. So I can say CLS. So rem program to solve for exponential. So now, coming to your line 20, what do you have? We want to collect the value of x, y, and n. We want to collect it at the same time. So we can now say input. So to make interaction, enter the value for x, y, for okay, you can yes, x, comma y, comma n, and you close it, and you now say x, comma y, comma n. As you know, so far these are in double quotation, they are string. They are the first thing that the program will run. They are the first thing that the user will see. Okay, what is this program is for? The program is enter the value for x, y, and n. So the user will know, okay, this program is asking me to input the value of x first, y next, and n. So and at the same time, you can see set as we were using before, you can set your line 20, input value for x, your line 30, input value for y, your line 40, input value for n. You can still do it, but to make it more faster, so you can use this method. So now coming to line 30, already skips the line, we've already skipped two lines, line y and line n, already joined them together in this line 20. So now we have to solve the real equation. So we can set z equal to this. You have to set something is equals because you have to print something. So printing something, you have your exponential. So let's what? Your z equals what? I said e. You cannot just write if into Q basic, you just say it as error. So, but you bring in the input function, which is exp, exponential. So exponential, open your brackets. X raised to power 2, you know, this symbol is for raised to power 2, plus y, then close the bracket. Then subtract minus sine what? Sine, open bracket, x plus n multiplied by y. You see, let's say I told you to calculate this, it will look a little bit complex. So, but to make it more easier for the compiler, you can still break it. It's possible you can break it. So in breaking this, you can have something like this. You can have something like this. We now say let probably maybe m equals exponential open bracket x raised to power 2 plus y, then close brackets. So our line 40 will now be let n, I cannot use n to make it more, let's use p. Let p equal to sine what? Open bracket x plus n multiplied by y, close bracket. You see, what we just try to do is that to just break it down. We use this one to represent m, while we use this one to represent p. So it will be easier for the compiler. So now, coming to line 50, what do we have in line 50? So line 50, we now said the major thing the major thing that we're trying to find is this z. So we now said let the z that we need equals m minus p. Very straightforward. You know, what joined them together is this minus sign. So, and we input it together. This m, this is now our new p. So what else? You print. What do you want to print? The solution equals or is z. Z is what we need. So then your 70. So the 70, you end your programs. And that's how the programs end. And you are going to see the answer. So looking at from where we start from our CLS, go to our rem. Rem is just a remark for the program that you want to do. And 20, we don't want to collect the variable separately. You can collect the x separate, you can collect the y separate, and you can collect the n separate. But we try to merge them together so it will be faster. So we now say, okay, input, enter the value for x, y, n, y. So we try to put comma to separate it. So you yourself, the user, you understand that after x, then you need to input y, then you need to input n. So I will now tell the basic program that follow the sequence of x, then y, then n. It's not like you said x, n, y here, and you now wrote x, y, n. No, there will be mistakes. So anything that you put in this string is what you are going to put at outside, so there will be no confusion. So the system cannot be wrong. You, the user or the programmer, you are the only person that can be wrong. So that's when we call, when they say some program has syntactic error. So now coming to line 30, we have our m equal to exponential x is power 2 plus y. But looking at our equation, there is no m. We are the one that bring in the m. Why? Because we want the work to be easier for compiler. That's why we bring in another variable. That's why we bring m. We represent this one with m and we represent this one with p. So now, come to line 50, you see, we just said let z equal to m minus p. So it's very straightforward. So, and then we print our solution with a z and 70 m. So, with all the examples that we will discuss, so I think you'll be able to know the uses of this inbuilt function. So the exponential is there, the integer is there, the absolute is there. About the absolute, yes, so you can say ABS. Okay, if I say ABS, open bracket, plus 0.4, or ABS plus, minus 0.4. So in returning the answer of this will return 0.4, while this will return 0.4 also. So that's what absolute does. So coming to int, let's assume that I said int open bracket 3.75. So, and I said probably maybe int okay. So in returning this will just bring out 4 because integer does not allow decimal. So what allows decimal is that you can use your probably maybe in next class we'll still discuss about it. You can use your floats, you can use your floats, and you can use your double. So though this one they allow the decimal, but int will remove it. So that, and you have your SQR, you already know SQR x. This x is anything that probably they said you find square root of 39, or the square root of 49, square root of 181, square root of 225. So this x is what you are finding. Maybe it's 225, so you just input it. Same thing go with all this sine, 30, cos, or tan, or anything that you need. So these are the inputs. You need to know it often. Anytime that you need it, you can just input them. And what's the equation that you need to find, just put it in front of them, and they will surely bring out the solution for you. So it will surely come in handy. So I will list notes, and from the notes you see the other inbuilt function that we have. So thanks.